And we're live. Hi, everyone. Thank you all so much for joining us. And welcome to 60 Minutes of Unscripted .NET Entertainment. As doctors of .NET, we prescribe healthy choices in .NET. Me, I'm your host, Cecil Phillip. And with me today, I have my co-hosts, Cam Soper and also Luis. And I'd love to welcome our guest, Steve Gordon. Steve, how are you doing, man?
I'm good, thank you. How are you doing?
Doing pretty good. So for people that may not have met you before or are not familiar with your work, why don't you introduce yourself really quickly and tell folks a little bit about yourself?
Sure. So I'm a .NET dev through and through. I've been using .NET since it was a thing, really, in sort of personal projects initially, and then into sort of actual production systems over time. For the last few years, I've been building microservices and ASP.NET Core microservices, so doing a lot of stuff with containerization of .NET and that kind of thing. And that's led on to a lot of blog posts on those topics as I've learned them along the way. And most recently, I've joined Elastic, which you can probably tell from the T-shirt, where I'm working on the language clients team now, looking after the .NET language client for Elasticsearch.
Awesome. Well, I know I definitely have a lot of questions that I want to ask, and I'm sure a lot of the folks that are in our audience today definitely do too. As I'm looking at the chat really quickly, I can see we have some folks from Thailand, Brazil, the Ukraine, tons of folks here with tons of questions for you. So I hope you're ready. I hope you're ready and set to go.
I'll do my best. I'll do my best.
So before we do that, why don't we jump into the checkup section?
All right, so this week's doc comes to us from Azure Search, and if you take a look at the link on the banner there, you can access it. Essentially, what we have here is a quick start on how you can create a search index using the Azure Search Documents Client Library for .NET. Now, today we're going to be talking about Elastic, so you might be asking yourself, well, why are we showing off this Azure Search or Azure Cognitive Search? And part of the reason there is one of the capabilities that Azure Cognitive Search gives you is full text search built on top of Apache Lucene, which Elasticsearch is also built on top of. And Steve's going to talk to us a little bit more about that. But essentially, if you want to get started with Azure Cognitive Search and building indices, you can go ahead and take a look at this quick start. The source code is available in the samples repository here in GitHub. And you're going to need a few things because it is an Azure service. You're going to have a cognitive search service as part of your as part of this application, and you also, of course, need an Azure account. So essentially, the way that you start by installing the Azure Search Documents package, and essentially get started that way. And the first thing you want to do is you want to create a search client, which is what's going to help you query the documents that are part of your search index. Now, to create an index, in this case, the scenario is you have some hotel data. And if you take a look at here, sort of what the schema of that looks like, you have hotel names, description, category, whether parking is included. So you could imagine some sort of travel site, that's available out there. And as a user, you'd like to be able to search or query different hotels based on varying criteria. So using, again, the Azure Search Documents package, you go ahead and create an index. In this case, again, you provide sort of the schema of what the data is going to look like. And then what you want to do is you go ahead and create the index, right? And essentially here, you just go ahead and say create or update the index, and you use that search client that you initialized up top to essentially create your index here. After that, you're going to want to have some documents that you're going to query over. So you go ahead and you create a few of these. Now, these could be loaded from files, perhaps from a database. But in this case, this is just a small sample of what those documents would look like, that you then go ahead and index the documents. And once you have the documents up there, then it's just a matter of searching. Now you can do that both within here. And I believe that there's a UI as well that allows you to search and query the different, essentially, documents that you have in your search index. So yeah, that's how you go about creating a search index using Azure Search. So with that, let's go ahead and get into the hallway track.
All right. So, Steve, I know you work for Elastic, right? And in the past, I've heard a lot of different things about like, what is it used for? Where does it kind of fit into your architecture? And so I really want to dive into some of those pieces. But why don't we start off with you just giving us a brief introduction into what exactly Elasticsearch is?
Yeah, I've got a couple of slides if you want me to share those, or I can just ramble.
No, please go ahead and share.
Cool.
I like rambling too, but we could do both.
Bear with me 2 seconds while it decides which screen to go. Can you see those?
Yes.
Perfect.
Yes,
cool. So I won't do tons of slides. I don't like using lots of slides in these kind of things, but for people that have heard of us, probably most people have heard of Elasticsearch and hear the word search. And that's very much what we're about at Elastic. But we build a number of products that sit on top of what we call a single stack. So we have products like enterprise search, observability, and security. And these are all things where you might want to spend time searching documents. And that one stack, which is easiest to visualize like this, is those kind of four main blocks at the bottom. And these are the pieces that people have probably heard of, maybe referred to as the Elastic stack, which is kind of what we refer to it as now, but previously the ELK stack because of Elasticsearch, Logstash, and Kibana. The bottom two there, Beats and Logstash, are about getting data into your data store. So collecting, monitoring information from servers or log data you may have from servers or applications that you want to kind of consolidate somewhere. And that place is typically going to be Elasticsearch. That's the document store with full text search capability, as Lewis mentioned, built on top of Apache Lucene. And then for visualization and viewing that data, we've got Kibana, which is kind of, as I say, that UI layer and sort of building dashboards, kind of exploring and discovering the data sets that you have. And then on top of that, we have our Elastic Enterprise Search, Elastic Observability, and Elastic Security products, which all built on top of that same stack. So just like many of our customers build their own products on top of that stack, we've built these to kind of provide for those main three verticals there. And then in terms of where you run this stuff, because this was a question that often people ask as well, many of our customers in the past will have probably gone to the right-hand side of these lower four items. So self-managed Elasticsearch, where you would install Elasticsearch on one or more nodes in your data center, or possibly as virtual machines in the cloud somewhere. And then you run that yourself and you're in full control of that. But that means not only do you have full control of configuring it and deciding how it works, but you also have the full responsibility of keeping it up, sizing everything, working out how you scale that. And then on the other side of that, we have Elastic Cloud, which is our latest way of running this stuff, which allows you to just forget all of the hard parts and just concentrate on your data, which is generally the most important part. So you provision in Elastic Cloud, and you can host that in Azure if you want to as well, so it can be close to your Azure services. And we run all of the sort of the nodes for you and all of the configuration and keeping that stuff sort of online for you while you build your applications and focus on that. I can show you, I'll skip through this slide, but just some basic terminology because we'll probably touch on a lot of this as we talk today. Cluster is a group of one or more nodes. So this is where Elasticsearch starts to build more functionality on top of Lucene, which is more just the library around full text search. We provide the sort of distributed nature of how you want to scale that to handle many millions of gigabytes, terabytes, petabytes of data if you need to. So we have the cluster made up of nodes. A node is just purely a server somewhere that is running an Elasticsearch instance that's formed into that cluster. Nodes can have different roles. As you get more advanced, you may configure them with different roles to spread some load across your system. But ultimately, these are what provide the ability for you to index data into Elasticsearch and then search for it back out. The index itself is the collection of documents. You determine how you want to aggregate your documents together when you're storing them. So many people will, for example, if you're doing a blog site and you wanted to provide capability for people to search over that, you would probably have a single index that contained all of the core information about your blog post. So your title, your description, any tags that you want to associate, and then people can search over that. But as your data scales, for example, if you're doing log ingestion, you may typically use sort of patterns where you maybe index data into buckets of weekly indexes and things like that. And then we have sharding, which is how you distribute the data that's in an index across nodes. And this is what gives you fault tolerance and scalability. And you can determine how you want to shard your data, whether you've got more sort of data that you're worried about ingesting quickly or maybe searching more quickly, the strategies you may use there. And then finally, the document itself, which is, as an application developer, this is the piece of data that you want to store. So it's basically just a JSON document, JSON blob that you want to put in there. And we will index the fields in that JSON document so that they can later be searched. And by default, we assume that you want to provide full text searching over anything that's text in there, but you can control all of that. And we can touch on that more later. So that's the key terminology for you there.
I wanted to go back really quickly because in that slide that you had that was showing, like the different hosting models, I think like there's a lot of benefit there to being able to have something that I could run on my machine and something I can run in the cloud. Because when you think about like that developer experience, it's like, oh, I want to build or prototype a thing, but like I don't want to have to be connected to the internet to do it. Right. And so I always think like products that are able to do that give like so much more flexibility to the developer, because now it's like, hey, I could pull out a container, or I could run this executable locally, and I don't have to worry about like what's happening in outer space. And then now whenever I'm ready, I could just push that out and have someone else manage it for me. So I always think that's a huge benefit when it comes to like developers.
Sure. Yeah. And certainly that's something. Before I joined Elastic, I was a user and a developer working with Elasticsearch, and that's what we did all of the time. So you can pull down the Elasticsearch image, you can spin up, a single node cluster essentially on your local dev box and get started very quickly that way.
Now for folks who wanted to
go into your thing really quickly, I wanted to ask you, where do you think Elasticsearch kind of sits? Because I've had folks talk to me about it as in it's a database, and I've heard people talk about it like it's a search thing, like, so I've heard people compare it to Mongo, and I've heard people compare it to Lucene. And so officially from your perspective, like where does it kind of sit in terms of like, how do I build my stuff?
Yeah, I think the line's quite blurred really, because you can use it for whatever situation you want to. I've used it in the past where it was where we wanted search on top of an existing transactional set of data that we had, and so we would store the full transactional data into MySQL and other data stores that we had within the business, but we would save particular parts of that data that we knew we wanted to be able to provide search capabilities. We'd store that into an index that related to that data, and that's reasonably common for how people want to do things, because if you've already got an existing data store of some kind somewhere that you've built over the years and is working for the majority of your application that you have, there's no need to re-engineer all of that, but you can quite easily sort of sit Elasticsearch alongside it and introduce sort of rich full text search there. That said, I was also working on a system before I left my previous company where Elasticsearch was the data store. All of the data went into there, and we were building a large-scale metrics and kind of analytics platform. And Elasticsearch is really good for that kind of data. So we were firing in around 18 million documents a day into the indices, and then allowing our customers to actually search and aggregate over all of that data. And this was huge amounts of data. There was no need to store it anywhere else. Elasticsearch gave us everything we needed to work with that. And so a lot of people also choose that path where, particularly for sort of metrics-driven systems, log collection, that kind of thing, where it is the data store that they're using.
Got it. That makes sense.
So in that scenario, though, it's going to depend based on the need of the user. But are there any sort of performance or benefits to, say, using Elastic as your data store versus just having it as that full text search layer?
It can be extremely quick. I mean, its feature set is, I guess, designed initially around sort of search first type scenarios, but as I say, it's extremely capable of doing kind of aggregations of data. So if you've got any kind of analytical data that you're collecting in, it can aggregate on that very quickly because of its distributed nature. So ultimately what you end up doing is scaling your cluster based on the types of data access you're having. So if you are kind of search and aggregation heavy, then you might scale it in a certain way and provide more data nodes that are capable of performing searches and shard your data so that all those searches can take place over multiple nodes at the same time, and then it just kind of gets collected together before it's returned to the user. And that can be a really powerful way to run it. But you don't, as I say, you don't have to. If you've already got a system that's fully capable of that stuff, you might just use it for the search and the full text search capabilities.
Got it. That makes sense. So, Steve, I think you had some demos you wanted to show us, right?
Yeah, I've got a kind of an example we can kind of work through. We can kind of see what it looks like to put some data into Elasticsearch and connect to it. So I'll just fire that up over here and share the screen again.
Yeah, let's dive into it for sure. Because I know folks are like, okay, we could talk about it, but like show me.
It's always easier to see it. Exactly. So first thing I'm going to do, and I'll just pull this window over here, is as you say, we can run this stuff in a Docker container if we want to. For prototyping and playing around, I've found Elastic Cloud has been a really great way to get started. So I'm just going to quickly spin up a cluster so that we can kind of store some data. And you can see one of the first options I can. Yep.
Hey, sorry to cut you off. Could you zoom in on that just a little bit?
Oh, of course, yeah. Zoomed in all the windows except this one. So there we go. It's a bit clearer now.
Thanks.
Yeah, that's good.
No worries. So you can pick, we can run Elastic Cloud in any of the kind of major cloud providers. We'll choose Azure. I think that seems to be a good fit for this show. And obviously we can choose the region as well. So I'll stick mine in London, which is geographically close to me. For the stuff we're doing, it's not going to make a huge difference. And I'll just name this deployment that we're going to create. So we don't have to choose a huge amount. We've accepted IO Optimize, which is the default, which is good for sort of general cases. But if you're doing any of our sort of machine learning stuff that we have in Elasticsearch, then you can also get going with that there as well. Now I'm going to expose my credentials live on the internet. I'm going to assume no one's going to use them in the short time I'm using it, but I will get rid of this cluster. So obviously these are credentials you don't want to share around too often. And this is now just going to set up a deployment for me up in Elastic Cloud. And while that's happening, I'm going to connect my code to that. So I've got a little sample solution, and it's made up of 3 little parts. We've got a sort of domain layer that just represents some data that we're going to be indexing in a moment, called stock data. And you can see we're going to be loading this data from a tab separated file. So we've got a very basic code that handles that and design a sort of domain that represents what that data looks like. And then ingest is where we're actually going to set that code up so that we can take instances of those objects and put them into Elasticsearch. And so one of the key things that we're going to do is we're going to need to connect to the cloud instance. So what I'm going to do is I'm just going to go into my stock ingest here, and I'm going to go to manage user secrets. And the 2 things we're going to need is we're going to need the password and the cloud ID for Elasticsearch. So I'm not wondering why my paste is not working there. There we go. And hopefully while that's finished, this should be nearly done by. So I'm going to pump that over there as well. So we've provided the cloud ID and a password, and I'm going to store this in user secrets so I can access it from configuration, but it's not going to be checked in. We're going to assume this is sort of development time work. And then the first thing we're going to need to do in the ingest project here is reference a package. So I'm just going to copy and paste one that I've prepared earlier, which is the package reference to Nest. Nest is our .NET high-level client for interacting with our Elasticsearch product. Most developers will want to be using this. We do provide Elasticsearch.net, which is our low-level client, which in high-performance situations might be useful, but it doesn't provide any of the strong typing, request and response models that we have inside Nest, and so most developers will want this. I've chosen the latest version of that, which is currently 7.12.1, which aligns with our 7.12.1 release, although it is backwards compatible to any of the 7x Elasticsearch versions that are running. And then the next thing we're going to need to do in this project is configure it so that we can actually use the Elasticsearch client. So I've got this to do here, and I'm, for the interest of sort of time, I'm just going to do a copy and paste here, and we can just kind of talk through what this code does. So this ingest process here is a .NET worker service. So if you imagine a scenario where we have data that's, we're going to be loading from a file from a demo, but more often than not, you're loading data as it kind of flows into your system from somewhere. And that might be through a service bus, a queue, or it might be files getting dropped somewhere that you're picking up periodically. And something like a worker service is good for that kind of continually running data ingestion, data processing type work. So I've used a worker service project template, which means that we have access to dependency injection as well, which is quite convenient. And so inside this DI container, we'll worry about the hosted service in a moment, but what I have here is a singleton registration of iElastic client. So this is the client interface itself, and then we need an instance of that. And because I want to provide some configuration when we create this single instance that we're going to have in the application, and some of that's coming from iConfiguration from the configuration system inside this worker service, I'm doing this where it's basically a factory for this instance. So we can access the config, which is just the same configuration you see in an ASP.NET Core project or the worker service project. And then we can set up some connection settings that we need. So in this case, what we're saying is we're gonna use the connection settings that accept a cloud ID and our basic credentials for now. So the cloud ID is that ID that I grabbed and stored into my user secrets so that it's accessible under this key. We set up the basic authentication against the Elastic user. And again, we're going to grab the password out of the user secrets. And then these we don't need to worry about too much, but basically what I'm saying to my configuration here is that if we do any access where we try and store documents, for example, and we don't provide the index, this will be the default index name that we assume we're using in Elasticsearch. And then I've also provided this mapping around what stock data looks like. So this takes our stock data type that we've defined down here with its properties, and it will automatically figure out, based on the types of those properties, how to map that data in a fairly generic way. So strings get mapped as full text searchable fields in Elasticsearch. Something that's a date will be treated as dates, that kind of thing. That's fully configurable. You can go in and create your own mappings based on how you want your data stored. Sometimes you may choose not to even index certain fields because they're never going to be searched. They just want to be present on the document when it is retrieved. You can control all of that through mapping behaviors. All I'm doing for this one is saying when we store anything that's a stock data, then use this index name, stockdemo-v1. And ultimately then this factory method just returns the new Elastic client taking those settings. And that's all available now in DI. I'm just going to tweak these for a second, because what we're going to do is I've got because this is a worker service, we can use this add hosted service functionality to basically set up an instance of a background task that's going to be running when this application gets loaded by the host. And we can take a look at what that looks like now. And so in here, you can see we're able to inject things because it's fully dependency injection capable. And one of those things that we're injecting is the iElastic client that we're going to need. I've also injected this stock data reader, which knows how to read this tab separated file here, read the file, read each line, and basically create an instance of the stock data object for each row of data that's in that CSV file. And all the CSV file is just a sort of a file of stock data for 5 years across the top, I think, Fortune 500 companies are in there that are on the stock market. So it's basic test data that I just grabbed that I wanted to put into my storage. Before I go into indexing the data, do you have any questions or anything you wanted to throw out at this point?
I do have a couple of questions, but I just saw a question pop up from YouTube from Giovanni. And Giovanni's asking, is there a hosted solution that is affordable for a small index like a blog site? All hosted solutions offer clusters, but cost a minimum of $200 a month. So do you have any I don't know what your pricing situation looks like. Could you talk about that really quickly?
Yeah, so I don't know like the dollar amounts off the top of my head, but it's definitely less than 200. So when you set up Elastic Cloud, by default, we're going to build you a small cluster, but that is distributed across availability zones. So this gives you resilience if one of those zones goes down. You can opt out of that. So if you're doing something that's just prototyping, you can say, well, I don't need it in multiple zones for now. I'll just have a single running instance. And you basically set a slider for how much data you want to store. So if you've only got sort of less than a gigabyte or so of data that you'll be actually storing in your indices, you can select the size that you need, and we'll provision a very small VM for you for that. And we'll give you estimates around on what that looks like in the actual cloud portal, so you can kind of get a feel for what you're going to be spending up front. I found it pretty affordable as a kind of testing solution. As I say, for pure dev situations, if you don't want that cost at all, you could just use the Docker images and the free license of Elasticsearch to get started. And then once you're at a point where you're ready to productize this thing, or as you say, if it's a private blog and you're happy that Elasticsearch is allowing that search that you want, you could then look at a small cloud instance to get up and running with that.
Cool, awesome. And another thing I wanted to ask you about, so when you're showing how you created those default indexes in your program, that CS file, are there ways to create indexes outside of that? Like, can I create dynamic indexes or anything of that sort, or do they have to be set up when I create that client?
You can, and we will get to a little bit of code that shows off a few of those capabilities in a moment, actually.
Got it. Okay.
Cool. Okay. Well, if you're good, yeah, I'll put some data in, and then we'll look at doing some of those other functionalities as well. So what we're going to do is, because we've got a lot of data, we could basically read each document out of that CSV file and send a request to index each essentially individual line. So this, as I say, there's 5 years worth of data times 500 companies. There's thousands of lines in that file, and so doing so would work, but it wouldn't be super efficient, mostly in the sense that you've got many thousands of HTTP connections involved, because you're sending a single document per request. So what I'm going to do in this to-do section here is, when this application runs, we're going to do this thing called bulk indexing. And bulk indexing itself is basically a case of you gather up a group of documents that you want to store, and then you send them in one single request. And you can manage all of that through the client directly. But we have provided this method called bulk all here, which is what we refer to as a helper, because this is a very common situation. And so this is a helper that basically allows you to provide an IEnumerable of your data. In this case, it's going to come from this stock data reader. With that provides the IEnumerable of data that we're going to be indexing. And then we, on your behalf, will set up potentially multiple threads and batch that up for you into sort of smaller, larger requests, but fewer of them. So in this case, what I'm saying is, okay, here's my source of the data, which is this IEnumerable of data. We're going to be sending to that stock demo v1 index. And we haven't actually created the index at this stage, but that will happen automatically if you send it to a name that doesn't yet exist. Elasticsearch will create an index against that name using default settings. And the key things here we're saying are, in this particular case, we want to have a max degree of parallelism of 4. So we want to set off 4 threads that are pushing this data up, and we want to batch it to size of 1,000. So each request we send to Elasticsearch will contain 1,000 pieces of data, 1,000 documents. And that may take some time. So what we then have is this additional helper that allows you to basically sort of wait until that's done. In this case, we can't really do anything with the application until the data's in there. So I'm just going to sort of forcibly block it for up to 30 minutes while that data gets stored. And then this last line will become a little bit more reasonable in a moment, but we're going to put an alias against that as well. So an alias is really just a way of naming or pointing a sort of a friendly name to any of your indices. And in this case, we're saying we want anything. So this is the alias. So stock demo is the alias, should point actually at the underlying index called V1. And this will become sort of, you'll understand why in a moment. So this is all we need to actually index a large chunk of data into the application. And I'm actually just going to kick the ingest processor off now while we talk, because that's going to take a short while to fire that data into the cloud. Let's just make sure that starts. Nope, because it's a good start. Bad authentication. So obviously whatever I copied earlier was not what we wanted. So let's just double check that I've set things up properly here. So my user secrets, did I save the user secrets? I did. It looks like I possibly double pasted that username. And my internet's being funny as well. So that's also not helpful. So if we come back into here and I'm just going to reset my password on this just to make sure I did copy the right thing. So that's what I need now. I'm not going to download it, but I'm just going to recopy that, and that's definitely longer than the normal encoded password there. So got an authentication failure because I failed to copy and paste properly, which is a skill all developers should have naturally, and that's a bit more like it. So now the client has been able to talk to the cloud under that cloud ID that we had configured. It's authenticated under the Elastic user, which by default has pretty strong rights to create indices and put data in. And now it's just churning through and sending that data up to the cloud. So we can probably go and have a look at some of that data, even though it's still going in. Let's take a look at what that looks like. So in this deployment here, .NET Docs deployment, I'm going to open Kibana. So Kibana is that UI that's useful not only for working with your data, visualizing the data, and sort of understanding it, but also for doing sort of management functionality. So configuring options, configuring some of the more advanced features that you may use in Elasticsearch. If you would rather do that through a UI, you can with Kibana. I'm going to use it here just for its dev tools, which is a really nice way to get started with interacting with Elasticsearch, so just while my app's kind of busy pushing data in. So this is an example of a default query that's going to search across all indices and look for all documents. I don't want to actually run that because that could be quite large. I'm going to paste in a query that I created earlier. And you can see what we're saying here is this is the name of the index, so my stock demo v1. We're going to perform a search action, and then the body, the payload for this request is this query. And we have a domain-specific query language and structure. And in this case, we said what we'd like to do is provide a bool filter, which says, give me any documents where the term of the symbol.keyword is Microsoft or MSFT. So give us that back. So I'm just going to run that request quickly. And that's going to look over, in this case, we found around 1,300 documents nearly have been indexed into the index here. And what we get back is get an array of hits. So this is one document representation. The source is the JSON payload here of the thing that we actually sent in through that bulk request that we sent up. So this is just one document representing 1 day trading for Microsoft with the high, low, and close values and things like that. We get this unique ID for the document created for us. You can provide an ID if you want to. And in this case, a score of 0, because typically when you're doing full text search, you're very interested in relevancy. So, if you go back to the blog post website example is a good one. If someone searches for say, Elasticsearch on your blog, it would be good if posts that contain the word Elasticsearch appear, obviously. But we might want to say that any documents that have Elasticsearch in their title should rank more significantly than those that just mention it perhaps in the body of the article. And possibly, again, if they're tagged, that should have some significance if they have Elasticsearch as their tag or category. And so the score in that situation is worked out based on where the word that we found appears in your document. And if you've attributed certain fields as being more relevant or more important than others, then that will boost the score of those ones. So ultimately, what you would want to do is serve those highest scoring hits at the top of the results that you're returning. So at this stage, we've got data in, and we can get data out. So that's kind of the starting point. I guess any quick questions about that stuff before we carry on?
Yeah, so I'd love to know, how do you calculate the score, or how can I manipulate the scores if my data obviously might look different to yours, and like can I say like this particular property within this payload should have a given this value should have a particular priority or not? Like, is that a thing that we could do?
It is, yeah. So when you get into the slightly more advanced Elasticsearch, you'll define mappings for your data, which describe to Elasticsearch for this document structure. Although Elasticsearch is schemaless and it will take whatever you give it and store it appropriately, it will use defaults for how it stores and indexes that data. The mapping that you can provide is where you provide those overrides. So you can say for a given field, so this isn't the best example because it's a fairly simple data set, but we could say that any matches in the name field are more significant than anywhere else. And we can say boost situations where you find text in there that matches whatever's being searched, boost those particular documents by a factor of 2. And so that field has more relevancy for any search results where it's found. And then all of these other fields, if they contain that word, they will appear in the search results, but they will have a lower score overall than that field that we've designated as most important. And there's many ways that you can kind of configure that stuff based on different needs you may have. But most of that's done through defining a sort of a bespoke mapping for how you want your data to be searched.
Got it. And it looks like we have a couple of questions coming in through the chat.
Sure.
Danny on YouTube is asking, by experience, the batch size might differ a lot and throw errors if exceeded. Can you configure the max size? I'm guessing you saw what the max size of the batch.
Yep. So I guess this is for the bulk indexing size. So in this case, I've configured 1,000. So we will behind the scenes create a block of 1,000 documents that go up in a single request. And you can control this with whatever value you want. And you will generally want to do a little bit of testing because it's easier to assume that, okay, well, if I batch a massive amount together, then it's only one HTTP request and therefore it will be quicker. That's not necessarily going to be true because all of those documents still have to actually be indexed down into the final index. So depending on how your cluster's configured, how many nodes you've got that are capable of accepting that data, it may be more efficient to do many sort of smaller size batches, maybe 1,000, maybe 100 would work for your configuration. So generally I recommend to people, you want to sort of try different things with this, a bit like any kind of form of sort of load testing in your application. Based on your cluster that you've configured, you can try different sizes and see which one gives you the best ingest throughput, basically.
So that sounds like it depends kind of answer.
Yeah, it kind of is because everyone's data is so different, and because those cluster configurations can also be very different as well. We've got people that run very few nodes, and so the throughput's going to be limited by how many shards you've got across those nodes. But if you've only got a few nodes, you can only have a few shards for your data. Other customers will have hundreds of nodes and they might shard slightly differently. But even sizing those shards and things like that, you do need to sort of try different things. And we have recommendations on our website. We have sort of good defaults for everything. But then you need to kind of test that with your data sets to find the best performance for your situation.
Got it. Sure. And this other one just came in. Let's answer this question real quick before we move on. So Giovanni's asking, can you batch dynamically based on document size? Says some of my documents are really big, some are really small. So, one size doesn't fit at all kind of thing. Yeah,
it's a great question. This particular API is generally expecting fairly similar sizes for how it's going to load stuff. So there's no way to configure sort of based on the ultimate size of each sort of blob of JSON for each document. it's a really good idea for something we should look at and see if there's things that we can offer there. In that case, you're probably better off custom batching some of your data yourself. If you have specific needs and you have a specific knowledge about what your data looks like, you might be able to say if this property is present, it's always going to be a large blob of text. Maybe you want to grab all of those together and index them through one bulk call request, and then have another for your sort of smaller documents. But yeah, nothing in the box within the client directly that will help with those in a single request situation. Got it.
All right. No more questions in from the chat so far, but I do have one personal question I do want to ask you. So again, just try to visualize like what my architecture kind of looks like. So imagine I have a SQL thing, because most of our .NET audiences, I imagine, use SQL Server or some version of SQL. Would the thought be I can have Elasticsearch sitting in my architecture right along my SQL thing, and then now essentially like whatever it is, however I wanted to format my data or index it or whatever the case is, I'd have some job that copies it over, right? Puts it into Elasticsearch for indexing. And now like Elasticsearch would now be my search endpoint. You know what I mean? So like I insert into SQL and I search out of Elastic. Is that the general thought?
Generally, yeah. There's two main strategies I've seen people use in terms of how, in that situation where you've kind of got a key data store that is an Elasticsearch, and then you're using Elasticsearch alongside for rich search. Most people either go down the route of basically splitting the write. So in their application code itself, they might write to SQL Server, and then they might also index the data in. So if your application can take the fact that you've got essentially two things happening at once, that's a way to go. The other way people do it is to have something polling the SQL Server sort of as data arrives, pick up those transaction logs as new things come in, and then periodically sync that over to your Elasticsearch in some kind of background process. That works as well. You obviously generally have a slightly longer lag between the consistency of that data. So data that's been stored into your SQL Server might not be available immediately in search results that are done, for the next few milliseconds or seconds. But generally, those systems catch up pretty quickly. And the way I approached it in the past was we actually rely quite heavily on messaging. So when we were building more of a microservices type architecture, we had lots of individual services that were responsible for where that data might be created. They would put a notification onto a queue that then got published to multiple subscribers. And one of those subscribers was a service that was reading those messages off the queue and then putting them into the index at that point. So with that kind of strategy, you start to get more kind of event-driven architectures. And we found that worked really well with kind of a microservices pattern overall, because each microservice, all it had to know how to do was put the thing on the queue. And then through our sort of queuing design, we were able to have those different subscribers listening. One of those would store down to, say, SQL Server, one of them to Elasticsearch. Another then could, obviously do other kinds of notifications within your business as well.
Okay, got it. That makes sense.
Something we're working on all the time is different connectors. So I'm less familiar with that side of the business, and I need to definitely look at that more. But I think we have connectors for the common sort of platforms that are out there. So if you're already using sort of data streaming in your business, there may well be a connector that you can use, whether it's a sort of one owned by us or a third party that allows you to take data from one of those other data services and then start to store it into Elasticsearch as well, which can be quite useful.
So since you kind of mentioned that, I'm kind of wondering about some of the other tools in the toolbox, and I don't know if this is something you get to or not. But so there's also Logstash and Beats. Now, is Beats an ingestion tool, so to speak? So for instance, like if I have things that exist in other stores, is Beats like a tool that I could point stuff to and be like, go get it, and then have it ingested into Elasticsearch and then now have that surface through Kibana? Is that flow?
Not exactly. I mean, it is what I would consider kind of an ingestion tool, in that you would install Beats. We have different Beats for different sort of needs, but you could say install a Beat on agent onto one of your servers if you wanted to collect, say, CPU and memory utilization on that server, and Beats would collect that data from the underlying system and then push that over to Elasticsearch. More commonly for sort of ad hoc and slightly sort of less usual situations, Logstash can work. So if you have a mechanism where you can write log files, or you already have you're using a product that writes log files. One example we had was we were using CloudFront for web-facing traffic, and that can produce large log files of all of the requests that are coming through. And so we were using Logstash to read those log files in. And it can do data manipulation for you. So one of the common things is like maybe you want to do geo-IP lookups and that kind of stuff if you have IP addresses in the data. And Logstash can take that stream of basically those log files as they appear on some storage mechanism that you pointed at, read them, and then stream that data into Elasticsearch as well.
Got it. Okay.
So real quick there, speaking of other capabilities, you mentioned at the very beginning machine learning, and my ears sort of perked up there.
Yeah.
What are the capabilities in terms of machine learning that Elastic or the Elastic sort of stack provides? And can you use those capabilities using .NET?
So the first question I will take the fifth on and say I'm really not that well versed in the machine learning side yet. So it's one of those things, you join a new company and you see all the shiny stuff they do, and it's on my list of things I need to learn more about. It's pretty feature rich from what I've seen, but the exact stuff I think you probably I'd rather refer people to the website to get an understanding of what's there. In terms of using it from the .NET client, yes, you can. So pretty much, basically Elasticsearch, all of the functionality of Elasticsearch is exposed as RESTful APIs, basically. So there's an API for all of the functionality that you can handle within Elasticsearch. And so our client basically has these strongly typed request response methods for all of the stuff. Typically, as soon as it's GA as a feature, we will make sure we try and have a high level method that you can call, where you can do this kind of fluent configuration of how you want to send data in. We'll see some of those when we look at the read side in a moment, but yes, that's all exposed in the .NET client. And if there's features people come across that they're doing something in the machine learning space and they find that it's missing, or they're not getting quite the functionality from the .NET client that they'd expect, always welcome to raise an issue for that one on us, and we'll make sure we follow that one up.
We might know someone that knows a little bit about ML.NET. We should have the two of y'all talking. Maybe something magical could happen there.
It sounds like it could be a match made in heaven, I think, those two together.
Awesome. Well, no more questions yet from the chat. So I'll let you go ahead with what you were showing us before.
Cool. Okay. Well, let's kind of complete the picture, I guess, of we've now ingested some data. So the two things I'm going to do very quickly. So this program also includes a Reindex thing. So this kind of gets to your point earlier around some of the other APIs. So a very common thing you'll do is you'll index some data when you first get it, when you first start sort of prototyping systems. And then in the future, you'll realize, for example, where we were talking about maybe certain fields should rank higher than other fields, that you may want to map that data differently. You might want to, boost some of those fields and make them more relevant in search, that kind of thing. It's very common that you'll need to work out how you manipulate the data that you already have. And the one mechanism to handle this is basically to create a new index that has the settings that you want and re-index data into it. So in this scenario, I'll make the change and then we'll quickly compare what that looks like, and then we'll quickly do a read from the database. But this gives you a bit more of an overview of what it looks like to work with the client. So in this case, what I'm going to say is my first check is through this exist async method, we're going to check if an index exists that's named stockdemo v2. Where it does exist, we'll delete that. So we'll assume we'll start with a clean slate each time. So we can manage indexes through the client very easily. We can also create them programmatically. So in this case, now that we know we definitely don't have one that's already called stockdemo v2, we'll create one. And in this particular case, this is an example of our sort of mapping syntax, where what we can say is, okay, so from the properties on stock data, I want to set up a keyword mapping, which is a non-full text searchable mapping for the symbol. So it's very unlikely someone wants to be using our data set where they want to do a full text search across those very short 3 or 4 letter symbols. So what we can do is save some space in our index by not storing the full text representation of that data, which has to analyze the tokens in the text coming in and store that as additional sort of data. So in this case, we're saying, okay, for this particular field, which is just the symbol property of this data, make it a keyword only. We will create the index, and then we will kick off this reindex on server functionality, which basically says, I want you to take any data that you find that you've already got in this stock demo v1 index and push it into stock demo v2. And then we're basically going to push that off in the background. So this is actually handled on the server side. And then what we can do is from the client, we can query the server's tasks and say to the server, okay, what running tasks have you got going at the moment? And in this case, I'm just going to manually check to see if that task that we kicked off is finished. And if not, I'll pause for 5 seconds and try again. This is an example of an area of code that I want to improve. So this is kind of manual at the moment. I think we can make this into a really nice helper for the future so that you can just say, kind of wait till this thing is done on the server. And then the last block of code here is updating the alias. So earlier on, you saw that I aliased stock demo to point at stock demo v1. The reason I did that was because if I have this situation that we've got now where we want to kind of change how we've structured some data and we want to work with it differently, rather than updating all my application code that might be out there that says it has to now look at this new v2 index, what I'm going to use is the alias in my application code. And then this code here is updating where that points. So what I'm saying is, as a single operation, remove the stock demo alias from any indexes that it currently references. Then create a new one. Again, the alias name is the same, but this time it should point at that. So anyone that's talking to Elasticsearch and using the alias stock demo will seamlessly switch over to using that new index behind the scenes, which is quite a nice way of doing kind of, as I say, these kind of rolling changes as your data knowledge matures and you maybe start working with systems differently. I'm just going to kick this off because that'll take a moment or two to run, and then I'll describe how we're going to actually do the read side of this as well.
Well, while that's running real quick, our erstwhile co-host David Pine had a question. Does reindexing happen implicitly or automatically somehow? It seems like a manual thing, which could become very exhausting.
Yeah, so this gives the impression if your data needs a clear, then you don't have to change your index at all. So you can send documents with additional properties on there, and it will automatically just work. This tends to be a situation where you've learned something important about your data set over time, and you specifically want to change how that's stored or referenced on the server. So in this case, from a slightly longer demo that I do, the situation is we've learned that actually we were storing a full text information about that symbol property that we just realized we didn't need, and it was adding storage costs. And so one way to optimize that away is to actually be more explicit in configuring a mapping for that data. And then in this case, reindexing to use that updated mapping. This is normally something you would do in your sort of development prototyping stage where you're, as I say, learning about the data in your application, and then over time, as your sort of that knowledge matures and you're ready to release, you'll probably create your index mapping, and that will be what you use in production going forward, if that makes sense.
Yeah.
So it's certainly something you shouldn't be doing regularly. Shouldn't need to be doing this kind of code regularly. It's just to show off the client functionality more than anything else.
Right. And if you wanted to, you could create those indexes like through configuration on Elasticsearch itself, right? Versus just doing it through code. I'm guessing that's another thing that's available. So I could define these things, right? And
that's it. Yeah, you can create mappings in advance in any way that you want. So as I say, we're kind of schemaless in that we'll take whatever JSON you give us, and if it looks like text, we'll index it as full text, searchable text, and if it looks like a date, we'll index it as a date, and same for numbers, that kind of thing. And that's the default behavior. but you know your data better than we can. So if you've got a field that you know you don't need to ever search on, you might tell us that, and then we won't actually even store it into the index at all, into the inverted index at least. We will just store the source document for you. If you've got fields that you know never need to be full text search, but you'll use for aggregating your data, marking those as something like a keyword only field is a good way to go, to kind of save some space on the server side.
Yeah, that makes sense.
You can do it in code. You can do it through Kibana, or you can do it sort of directly through the REST API, which you just create a file that you push up.
Okay. And then you did make a comment a little bit earlier about like storing a little bit less information to save space. Is there ever a situation where, let's say I have a document, I only want to send the information over that I know will be indexed, and then now I return those results, but now I query the actual document from somewhere else? Is that a pattern that you see people use?
Definitely, yeah. So some people may, in the Elasticsearch index, you may just store, say it's a blog, the title and the body of the text, so that people can kind of search over that. The result you get back from us then will just contain, you may just ask for just the ID of that document, and then you may go off and call your SQL server with that ID and say, give me that record, and that will give you, the full transactional sort of record that you stored into your table or tables that you want to pull together to render in your UI. That's very common.
Got it. Okay.
Obviously, the downside of that is you're doing sort of multiple calls to different systems. So for simpler things, sometimes just using Elasticsearch on its own when it works for that situation is also a very good way to go. So very much depends on where you are in your development journey with the product. If you already have that data store, that's a really good pattern to kind of integrate the two together in the early days. If you're starting fresh, you might actually look at just using Elasticsearch as your pure data store and see what it provides. And then if you find you've got other data where you do want to be able to have sort of more relational data across your system, so that people can use it for other means, that's where you might then put in a relational database alongside it as well.
I feel like depends is like the word of the day. I feel like we've said that like a whole bunch, but I also think that's a good thing, right? And I think it's a good thing because one, it shows like you have the flexibility, but two, it also shows that as we're building these types of things out, you really need to sit down and think about, well, what are your goals? What are you trying to achieve to make sure you pick the right choice?
Yeah, I always urge people to think about both data in and both data out as the core thing. So what does the data look like that you have from the other systems? What type of properties do you have on there? What information do you have? And then most importantly, how do you expect it to be searched, and how do you need it to be searched and queried and aggregated over time? We're extremely flexible in that you can at any point in time, if you have a new business need comes along, you might create a new index that you start storing data into and re-indexing existing data into for that new requirement that's specifically shaped around that model that you have. And so you can evolve over time as your data evolves, but certainly in the early days of developing any project, it's most useful to know how you expect it to be searched. And that doesn't mean you have all those answers to begin with, but certainly try and design for those key sort of data usage requirements up front. Design how you want to store the data so that it can be retrieved most efficiently.
Right.
Cool. So I guess we're getting close to time. So I should probably show very briefly what the querying side of this looks like. So I've got an ASP.NET Core API project here that we'll use. While we were chatting, I've just quickly put in the user secrets for that match up with the system. It's already got the required services configured, so it's going to use those user secrets to connect. And the key thing here is you can see we're using the alias in this application. So even though behind the scenes I might have been switching how my data is modeled and how it's stored, my applications don't have to redeploy. As long as whatever we've done to that data is still compatible with how they were working with it in some form, which it will be in this case. And then in here, we've got a very basic controller where I've stubbed out a few things. So I'm going to, in the interest again of time, I'll very quickly copy and paste some blocks of code, and we just briefly sort of work out what that's doing. So So a common scenario might be that we want to search for stock data. And so what we might want to do is, in this case, say, give us all the stock data you have. What we'd like to do is get an aggregation, so group together the data by the symbols. So in this case, I'm creating a terms aggregation over my symbol property, so whatever's stored in that symbol field, with a max size of 500, which I know will be large enough because my data set has 500 symbols. These 3 lines here represent what we call the fluent syntax. So you can see it's this kind of sort of lambda expression-based way of configuring things. So you kind of you can access all of the different properties around what a search allows you to do. In this case, we're specifying a single aggregation. Some people like this, some people don't. You may be more happy working with sort of types directly. And so you're perfectly free to use our object initializer syntax, where you actually create this instance of a search request over some stock data and then configure the aggregation. So these 2 blocks here are functionally equivalent. They're just different ways, depending on how you prefer to sort of structure your code to design your application, basically. So you can use either. And then in this case, we just call search async passing in the request if we're using the object initializer syntax here. And we'll get back a response. And on that response, we'll have some aggregations. We can access any terms aggregations by our symbols key, which we used in our search up here. And then we just ask for the buckets of data, and I'm going to spit them out to the console. So if I quickly run this, assuming I configured everything behind the scenes while we were chatting, this should just fire up and give us our first use case. So I think it's under stock/symbols. What's puzzle today? Symbols. URL. Definitely stock. What is it under? Symbol. So that's my fault, not the application. So stock/symbol is the URL we got, and so this is, it's nothing exciting, but this is an aggregation of all those thousands of records we have. Here's all of the unique symbols essentially in there. So you can imagine someone may query this API to get the list of symbols, and then the next thing they may want to do is to search by a symbol. So if we just quickly paste in next block of code here, not found on the end. And so in this case, we're going to do a specific search where we're going to use the term that we're going to search on down here is actually going to be provided by the user of the application. So obviously this is a demo, so we're not doing any sort of safety checks necessarily. That what they're providing is a safe input string. And then I'm just going to pass that on into the search. And then when I get the results back, I'm just going to use a string builder here to build up a set of documents. So you can see we can use this again. This fluent syntax is what I tend to use. I can provide, this is quite a simple query. We can say, okay, give us 25 matching documents. In this case, we're sorting those documents by the date descending, and then we can kind of take a look at those. So if I just restart this application, now we've put this in, we'll be able to quickly look at that.
And I'm sure just like how you could specify the size, you could also do some type of paging, right? So give me the first 25 and then the next 25 and so on and so forth, right?
Yes, yeah. So we have capabilities. If you're doing stuff where you're extracting data, so you're expecting thousands and thousands of pieces of data. Maybe you're taking what you already have in an index in Elasticsearch and you want to do that storage elsewhere. Then you might want to look at either our scroll API, which is, again, it's a feature of Elasticsearch that's exposed through the client that allows for exactly that. So we have a helper that lets you basically say, here's the query I want you to execute. I want you to give me that back in batches of 100 or 500 or whatever size you care about. And behind the scenes, we will handle issuing potentially multiple paged requests for you, and then giving you that data as it becomes available. Even more recently, there was a feature added called point-in-time search, which improves on that capability even further. Probably a bit deep to go into in the time we have today, but if you've got those kind of scenarios where you're pulling a lot of data out, we've again got those point-in-time search APIs where you essentially get a frozen snapshot of the index's data at a point in time. And then you can scroll over it and page over it. So that's useful if you're working with data sets that are constantly changing. What you might want to do is use a point in time to basically freeze your view over the data while you're pulling it out. And the index is fully workable behind the scenes for other users, but you've got your own sort of discrete point in time as you're viewing it. And that's another way of extracting large amounts of data at once.
Gotcha. Okay.
And again, nothing particularly exciting, but there's the results of searching for the stock by descending date for the Microsoft symbol.
Got it. So, Steve, I know we are running a little low on time now. So I kind of want to ask you, folks are really interested in learning more about Elasticsearch and particularly around the .NET SDK. Is there a place that they can go to see code samples and documentation and, all the fun stuff that they could get to play around with?
Absolutely. So I'll bring this other window over here. So the key places people will want to look is the Elasticsearch net repo is where both the high and low level client code live. And this is where I spend my days working at the moment. So if you've got any issues with like functionality, bugs that you think you found, that kind of thing, feel free to open an issue on here for us. We also have the discussions tab. So if it's more of a how do I question rather than a fault or a problem with the library that you've discovered, we welcome you to sort of jump into the discussions there. It's reasonably new that we've added that. So it would be good to build up common questions and answers in there. And then in terms of sort of documentation, we have a whole section of our Elasticsearch documentation site is dedicated to the Elasticsearch client. So the easiest way is just to go to elastic.co and search in the search bar up here for elasticsearch.net or Nest and find your way to this, where we've got the full integration introduction, the words I should be looking for, to get you started. And then all of the APIs will be a bit more sort of fully described under there. So those are the two main places I'd recommend people go. And also, if you run into a particular thing and you're a bit unsure, feel free to ping me a DM on Twitter. It's at Steve J. Gordon there to get in touch with me.
Awesome. Well, hey, Steve, thank you so much for being on the show. Really appreciate it. And thank everyone for watching. Thank you so much for watching the .NET Docs show. Definitely check out our recordings. They're available on YouTube. You can also go to our website at .NETdocs.dev and see some of our upcoming topics and guests and, tons of great things that we have coming up in the next couple of weeks. Make sure you tune in next week, because next week we're going to have a special one. Our friend Christos is going to be on, and he'll be talking about the Microsoft Identity Platform. So if you're interested in learning about how you could plug in Microsoft Identity and secure your, all of your web things and your application things, definitely make sure you come and check us out next week. And I think that's about it. Are we done? I think we're done.
We're done.
Right. Well, thank you everybody for watching. Appreciate it.
Until next week.
Again, thank you again, man. I really appreciate you spending some time with us today.
You're welcome.